You're welcome to it, though you've got to go one long, cold trip. Clyde Tombaugh, discoverer of Pluto. The 19th of January 2006, the New Horizons interplanetary space probe took off from the surface of our Earth on board an Atlas V rocket. Just a year later, the spacecraft performed a gravity boost maneuver near Jupiter, which helped it along to reach its final destination. 9 years after that, the space probe reached the end of its planned route. And on the 14th of July 2015, New Horizons flew by the largest dwarf planet ever discovered in the solar system, Pluto, beaming back several thousand images of this celestial body and its moons. What objectives were the scientists planning to reach as a result of this elaborate mission? And what was the last thing the New Horizons space probe saw on Pluto? Cosmo, the first in outer space. Pluto is the largest trans-Neptunian object in the solar system. It is also the largest object in the Kuiper Belt. Just like most bodies in that region of space, Pluto is mostly made up of rock and ice, and its mass is relatively small, approximately 0.22% that of the Earth. Just to get a slightly broader picture, let's compare Pluto with the Moon. Pluto's mass is about 6 times smaller and its volume is about 3 times smaller. Pluto's total area is 17.7 million square kilometers, and we're briefly back to Earth again to compare it with the area of Russia, the largest country in the world, which is slightly smaller, 17.1 million square kilometers. As for Pluto's diameter, it reaches 2,376.6 kilometers, which is 1,097.6 kilometers less than that of the Moon. As for Pluto's atmosphere, it is for the most part comprised of gases evaporating from the ice on its surface. Today we know that its chief component is nitrogen. Apart from that, 2 other gases are methane and carbon monoxide. Under the influence of high-energy cosmic radiation, other, more complex compounds form from these elements. On account of Pluto's surface temperature, these compounds are not volatile: ethane, ethylene and acetylene. There are also the so-called tholins. On settling on the dwarf planet's surface, they have a peculiar property of giving it a brownish hue. The average surface temperature on Pluto is 50 Kelvin. That is 223.15 degrees Celsius below zero. With every kilometer higher up, this indicator increases by approximately 7 degrees, and so the atmospheric temperature is 40 degrees higher than that on the surface. This could be accounted for by the greenhouse effect caused by methane. We're used to thinking that Pluto's orbit is stable and unwavering. However, on closer observation it transpired that Pluto's movement is rather chaotic and can be defined in non-linear equations. It takes a lot of observation to be able to detect that. When carried out in short time spans, observations reveal seemingly regular movement. In reality, Pluto's orbit slightly shifts in every period. Eventually it changes to such a point that it is impossible to retrace its initial trajectory. This dwarf planet's rotation is quite peculiar too. Namely, it is retrograde, which is also the case for both Venus and Uranus. It means that they rotate in the direction opposite to that of the other planets around the Sun. A day on Pluto lasts 6.4 Earth days. Due to its remoteness and small mass, Pluto is a rather challenging celestial object to study. Even very big telescopes show it to us as a tiny spot, seemingly not much different from a regular star. We have been able to acquire a certain amount of data with the help of the Hubble Space Telescope. Nevertheless, the greatest and most important portion of information was made available after the launch of the New Horizons mission. The first photo of Pluto was made back in September 2006, when the space probe was testing its LORRI camera. As the spacecraft approached Pluto closer and closer, more and more features of this dwarf planet were revealed to us. Thus, the object's surface was seen to be far from homogeneous. Albedo, that is, diffuse reflection properties of the surface, varies from 10 to 70% depending on the area of the object, which makes Pluto the second object in the solar system after Iapetus in terms of contrast in albedo. This diversity causes periodic variations in Pluto's luminosity and spectra as it rotates. The dwarf planet's interior must be made up of 50 to 70% of rock and 30 to 50% of ice. Its dense rocky core must be embedded in an icy mantle about 300 kilometers thick. According to spectral data, there is water ice on Pluto's surface as well, but it is mostly camouflaged by a layer of more volatile ices. There is also frozen methane and carbon monoxide, as well as traces of other compounds generally forming with methane and nitrogen when exposed to powerful radiation. In particular, these are ethane, nitriles and tholins, which make Pluto look brownish. On the 15th of July 2015, the New Horizons space probe flew by Pluto 12,500 kilometers away from its surface. Both sides of the dwarf planet were photographed during the flyby, the one to be seen on closest approach and the opposite one. Thanks to these images, a vast, heart-shaped area measuring 1800 by 1500 kilometers was identified. It was later nicknamed Pluto's Heart, or Tombo Regio. The left part of this area is believed to be a crater filled with crystal nitrogen. Also, two mountain ranges were identified in this area. The height of the first reaches 3,500 meters, and it was given the name the Tenzing Montes. The height of the second one, dubbed the Hillary Montes, reaches up to 1,500 meters. The most notable geological object found on Pluto is Sputnik Planitia. This trench is likely to be an impact crater with a diameter measuring 1,492 kilometers. Sputnik Planitia is filled with frozen gases and is streaked with a great number of grooves which divide it into irregular cell-like areas measuring dozens of kilometers. There may also be cryovolcanism on Pluto. The last image taken by the spacecraft looks to be indicative of just that. The potential cryovolcano that can be seen in this picture was dubbed Right Mons. The surface in the picture is comparatively young by space standards and practically devoid of impact craters. This shows that the crust in this area was formed relatively recently. And if Right Mons really is a cryovolcano, its enormous size of 144 kilometers across and 4 kilometers high easily makes it the largest cryovolcano in the outer area of the solar system. Among other interesting features discovered by New Horizons, there is a blue stratified haze enveloping the whole of the dwarf planet. In the images, the haze is seen to reach over 200 kilometers high and is registered by the ultraviolet spectrometer to persist to the point of 300 kilometers above the surface. The haze is likely to be made up of particles of non-volatile elements that originate from atmospheric gases, the ones I've already spoken about. These elements gradually settle on the dwarf planet's surface, and that is the way this effect is produced. The New Horizons mission is scheduled to continue until 2026. Apart from studying the objects in the Pluto system, the spacecraft has already provided insights into other Kuiper Belt objects too. And even though its fuel supply is insufficient for a dramatic change, of course, the radioisotope generator's energy should be enough to last it for another 10 years. Immediately after the space probe had flown by Pluto, astronomers used the Hubble telescope to look around for other objects that could be observed within the framework of the mission. The first of them, Ultima Thule, is a binary asteroid in the Kuiper Belt, whose two components' diameters measure 19 and 14 kilometers. It was closely passed by New Horizons on the 1st of January 2019. Another object was the asteroid 2014 PN70, measuring 40 kilometers across. It was passed by the probe in March 2019. Excitingly, apart from that, having traveled 8 billion kilometers away from the Earth, New Horizons reached a great vantage point for better observation of the stars closest to the Sun, Proxima Centauri and Wolf 359. In April 2020, the spacecraft was also used for double-checking the distance to these stars. Apart from the objectives mentioned, this amazing mission stands a good chance of being able to reach quite a few more in the future. While the spacecraft keeps beaming back new images to the Earth, we will be able to conduct research based on the photos of the celestial bodies it has already passed. For example, the pictures of Pluto's largest moon, Charon, taken on their brief encounter with the space probe. If you'd like to hear more about this space object in later videos, let us know in the comments or just hit the like button under this video. And then very soon we will set out on another fascinating journey to the realm of this dwarf planet. Let's keep in touch.